Welcome back. This is MLOps Zoomcamp session 4, and in this video we'll talk about deploying our models in offline mode, in batch mode. Previously we talked about online mode, so we talked about deploying our model as a web service, and we talked about using our model in a stream of events. Now we want to cover batch deployment. And in this video we will again use the write duration prediction model. Even though it's not ideal, as we discussed, the ideal way of deployment would be a web service. But here we can think about this in a way, let's say we have the actual duration and we have the predicted duration. And we want to see how often our drivers, let's say, deviate from the ideal predicted duration. And maybe it's useful for our analytics. Maybe we can see that, I don't know, there are actually traffic jams or something like this. So for analytical purposes. So I know maybe this application is not great, but I think it's better to stick to the same use case and not to introduce a different one. So we will see how to deploy the model for predicting write duration in batch mode. And for that, we will take the notebook we started a couple of videos ago. So this is the notebook. So this is the notebook we created for getting our model from model registry. So remember this make pipeline. So this is the same notebook that we will use. We will take this, tweak a little bit, and turn this into from a notebook where we train a model to a notebook where we apply the model. And then after that, we will turn this notebook into a script, and then we will clean the script, parameterize the script, make it self-contained in such a way that we can just run the script and get the predictions. And this is just the first step of this. And the next step would be deploying or scheduling the script with Prefect. And this is not something we will do in this video. Here we will just focus on creating the script, but then in the next video we will put this into Prefect and schedule it. That's the plan, and let us start. So I will first copy the notebook that we created previously. I think it's web service MLflow or random forest, and here I will call this model, this notebook differently. I'll call it score, because so this is what we are going to do with the model. We're going to use it for scoring records. So I'll call it score. And now let me open it in Jupyter. So I need this token. I open it. Okay, now let's clean it a little bit. So I'll take the import and move it here. And we actually don't need it here. We will keep using MLflow. And let me actually execute the import. But the way we'll use it is in the same way as we used previously. So we will access the S3 bucket with the model. So I can actually get it from here. So I think we have this web service MLflow. And here this predict by. And I will get this thing. And I will put here. And then let me import OS. And here run ID. I don't remember which run ID we used, so I think it's in README. And this is the run ID, so I'll put it here. And this way we should be able to access the model. So let me check. I need to execute this. And while it's loading, I'll put it here. So what's wrong? My models don't exist, so let me quickly check it. I'll go to S3 and see. So I don't know, let me take this one. Now it works, cool. And we can quickly check model. By the way, here we have a mistake. So last time I made a mistake, I forgot to divide it by 60 because we are predicting the number of minutes, not the number of seconds. And by the way, this model, like the model we trained, was actually predicting the number of seconds, not minutes. But we will just pretend that our model is predicting minutes, because the accuracy of our model is not important for this video, but this is just for you to know. So I will remove this one. So these two functions stay the same. So here we read the data frame. Usually we don't need duration. So duration is the target variable. This is what we want to predict, right? And typically you do not have this in your data to which you want to apply your model. But here, because our application is kind of checking how much the duration is off from the predicted duration, we can keep it. But usually in practice, you do not have the target variable when you apply your models. So we will keep it as this. Actually, I think this categorical, like preparing categorical features, should belong here. It's kind of not good because we reassign the value for this categorical, but okay, it's not important. And then, yeah, here we don't have train and validation dataset, we just have data frame to which we want to apply the model. So I will remove that. Again, we also don't have target variable because we just apply the model, we don't train the model, and I'll just call it dictionaries. Right? And prepare dictionaries would be the function we use for preparing dictionaries. And then this part with training the model is not needed. So we just need to apply the model. I will remove all this from the model. And what we need to do next is we just apply our model to dictionaries. So I'll have y predictions, and then it will be model predict, and then dictionaries. And yeah, that should be it. Of course, I didn't execute this, but okay, what is wrong now? Yeah, we don't have the data. So I think we have data here. Okay, this is how we do this. And we have this ypred. What we want to do next with this is we want to create a data frame with results. So it will be a data frame, right? We'll call it data frame result. And now we want to write all the predictions to this data frame. And typically the first thing we would put here is the IDs of the things for which we want to make predictions. So in our case, we have rights. So we theoretically should have some sort of right ID, which we would copy from the original data frame and write it to the data frame with results. But here we don't have anything that looks like right ID. So we can actually have some artificial right ID. So for example, if we concatenate pickup date time, pickup location ID, and drop-off location ID, that should be quite unique. We should be able to uniquely identify the ride. Another thing is we can just add UUID. So maybe that's what we should do. So UUID is a unique number that when you generate, it is globally unique. So there is no way that two people in the world, two computers in the world can generate the same UUID. And this is how it looks like. So there is a module in Python. It's built-in module called UUID. And here you have UUID 4, for example, and this is what it gives. And then we can get the string representation like this. It should be str. And then we get this UUID. So this is a unique number that we can use to identify each row of our data frame. Usually this ID is already present in the data frame. Typically we would not need to add this ourselves. So we can pretend it's there, but I just want to show you how to add this to the data frame. So we can generate, we need to generate this amount of IDs. So I'll just call it n, and we can do for I in range n. That's probably not the most effective way of doing this, but I'll just create a list here. I'll call it right IDs, and then I will just append things here to this list and then add them to the data frame. Right IDs, append, and this thing. Actually, this thing is different each time you execute this. Okay, so now I should have a list of IDs. So this is how it looks like. I have a bunch of IDs, and then I will add a column here called right ID with these IDs. And now in our data frame, original data frame, we have it, but this is, it kind of was there, right? Yeah, we add this to the result, and this is how we can relate the predictions with the actual ride. The next thing, we'll probably need some meta information, like maybe for our analytics. So for example, we want to keep pickup date time, then we probably want to keep pickup location ID and drop-off location ID. And then here it will be, yeah, we just simply copy things from the original data frame. So this is something we later will use in our analytics. So it's handy if we already have these things in our result data frame. And then finally, what we can do is we can maybe write the duration that we have, like actual duration, frame duration, and then the predicted duration. And then the predicted duration would be, so I'll remove this thing, the predicted duration would be this ypred, right? And then finally, we are interested in difference between actual duration and predicted duration. And then this is something, for example, we can use for a dashboard or whatever. So this is our data frame with results. So we have, so not this one. This one is our data frame with results. So we have write ID, we have pick update time, pick up location, drop off location, actual duration, predicted duration, and the difference between them. And I think the difference is huge because the actual duration is in minutes and predicted duration is in seconds. But yeah, it looks a bit off. Yeah, let's not spend much time thinking about this right now. This is our output, right? And now we need to save this output. So I'll save it to let's say Parquet. And this could be, we'll probably need to create a directory, output. This will be output and this thing. Cool. Yeah, so this is the main flow. Perhaps there are a few things we can improve here. So for example, we can just get the output file and put it here as a parameter. So this will be output file and then input file. So input file in our case was, what is this one? Input file. And then perhaps we can replace this input file with a URL, because it's possible to give pandas a URL directly. So it will download the file and read this, so we don't need to download it ourselves. So let me go to New York taxi data. And I will get the data, let's say from February, green taxi data. I will copy the link and I will put here. And then output for this one would be February as well. But then again, we don't want to constantly, every time we run. So for example, when we do this for free for March, we don't want to change this manually here. So what we can do here is perhaps we can add a couple of parameters. So for example, year and then month, right? And then we can just parameterize it here. So I can say that, let's say this is an F string and here will be year. And when we want to have 4 digits for the year, and this one will be month, and we want to have 2 digits for the month. So if it's 3, we want to have 0, 3, right? So this will be our path, and we want to also have our path that looks similar. And let's test it. So input file, yeah, looks correct. What else? Maybe perhaps instead of doing it like this, we can have like for all the predictions for green will go here, all the predictions for yellow will go in a different directory. So we can actually write something like taxi type green, right? And then this taxi type will go here and it will go here. And of course for us we need to create a directory, output green, something like this, so then it will be saved there. Yeah, this is another parameter. We can maybe put them together with all the other parameters. So I'll execute this and let me check if everything works. So this UUID, I'll put it here. And perhaps let me put this inside a function, like generate UUIDs, this n thing, the size. And we'll just return write IDs, and here we will use this function generate. I need to execute this. Generate UIDs, and will be length of this, right? So I'll put this here to all the other functions, and I'll move this down a little bit here. This is where we apply the model. So now we can clean it a little bit. So for example, we can have a function that will call apply model. And here what we'll have is input file. Then here we'll have a model. model URI, let's say. And then what else we need here? Perhaps output. Here maybe not even model URI. And the other thing that I forgot here to add is we also need model version. So let me add model version here, result, model version, and this would be our run ID, right? So now I don't know what's the problem is write ID. Yeah, we need to properly execute this one, and this is how our result looks like. We have our model version. You see, this is the same value for all the rows, because we use the same model for predicting the output for all the rows. So perhaps instead of model URI here, we need model version or model ID, and then here we would build this string inside. Yeah, so perhaps we can have something like the float model run ID, and then this is what we return, and then yeah, run ID here and output file. Yeah, it's actually not even run ID, because we need version here anyways. And this ID I would add here in read data frame, because we assume it's already there. So that's why we'll add this into the read data frame function. And then I guess we can have another one, prepare results. For now, let me just put it here. And then we will write the results. So load model will, yeah, we can just maybe load the model here. Model, load model run ID, and we can put run ID here and return this data frame, or maybe save it immediately. I don't know. Yeah, let's just save it to Parquet. So we'll use this one, and we save it to this output file. And then perhaps what do we need? Yeah, index. Usually index should be false. We don't want to write the index. That's roughly it. So we put all the code in the functions, and there is almost no code outside of functions, so only this one. So there are no global variables. Let me just restart everything, so to make sure that it works. I didn't accidentally make any mistake. So now I execute everything, and then yeah, what I want to do now is this apply model. So this is our like main sort of function. And then the input file will be this input file, right? Then run ID would be this run ID that we have, and output file is output file. So let's test it. Yeah, looks like it's working. So let me just quickly check what we have in our output green. Yeah, we have it for March. And yeah, if we want to, let's say, execute this for February, we just need to yeah, execute it one more time. Just change the parameter to February, and here we go. Yeah, we have it for February. So this is how roughly it works, but of course it's not convenient for us to open a notebook, go there, change the parameter, and execute all the cells one by one. We want to turn this into a script, so let's do that. Now I will go to the terminal. So I'm in this directory right now. We have this core IPython notebook, and let's turn this into a script. This is we'll do this using Jupyter NB convert, and then we'll use the to parameter to script, and then we just do score IPython notebook, and then this should create a Python file, score.py, which we can open now with our VS Code, and we have all the code here, which we can now tweak and clean. So we have the parameters here. I will actually move this down, and I'll remove this. We can just create let's say run function where we will put all that. And this year, month, yeah, we can parameterize it. Right now, let's not do this. Right now, I'll just do apply model. I'll do this. It's not important, it just looks a bit cleaner. And yeah, and now we add this if name equals main. We run the run function. Now that should work. Now let's parameterize this. Let's parameterize year and month. Taxi type, yeah, maybe we can parameterize that as well. So I'll just need to import sys. So with when I import sys, I can access the command line arguments, and this is what I will do. So here in command line arguments, this is argv, and the first argument will be, let's say, taxi type. Then the second argument will be year. It's argv2 year. I'll convert it to integer. And the third argument will be argv3. I don't know, month. I could use argparse here or click or something else, but I'll keep things simple. I'll just use the default thing argv. And yeah, let's test it. So I'll just go to my terminal, and first I'll remove everything from our output green. Yeah, so I'll remove everything. Now when we see what's there, there is nothing. Okay, did I remove too much? No. So now let's run this core.python for green 2021 04, for example, or just 4. I should have added logs here, like at least even print statements. Yeah, of course, we need to say where it is. Yeah, that should be run ID. That's one thing, and we also need to perhaps remove it from here and do export run ID. Maybe it's actually a good idea to, instead of doing it through environmental variables, we just stick to the same way of parameterizing our script. So we will also do, for example, we'll get run ID as an argument, as a command line argument. So yeah, actually, because now we have so many arguments, it would be better to use argparse, because there are already 4 arguments. Yeah, I kind of feel lazy to do this right now, but yeah, in principle, we should do this using argparse. And yeah, let me re-execute this script. So I added this as another parameter. So we have Python score, and then green, this is our the taxi type, year, month, and model ID. It's kind of not clear what's going on. We perhaps should add some logs. So I will quickly do this. So first we are reading the data from, and this will be our input file. This is our f string. Then, I don't know, loading the model with run ID. This run ID. Now we applying the model, and then finally we save the results, right? Saving the results to, and that would be our output file. Okay, so let's run it one more time. So now we should have some logs. Yeah, that's clearly better, right? And then we can do it also for May, June, July, and so on. And the good thing is about this is just it goes to the internet and downloads the data, applies the model to this, and saves the result. So yeah, the next thing we should do here is actually upload this to S3. So right now this is it just writes it to local file system. Ideally it should be S3. It's relatively simple. I don't know if I should spend time on this right now. Maybe I'll do this in the other video. But yeah, it should be S3, and it's more or less ready. So what you can do next is you can take this script, this core.py, then you can create an environment. It's actually a good idea to create an environment with pippin, for example, and then specify all the dependencies that this script has. In our case, this is pandas, this is pyarrow or fastparquet for reading and writing to Parquet. Then it's MLflow, it's scikit-learn. What else? I don't think we use anything else. So this UUID is built-in thing. Yeah, that's pretty much all the dependencies. Yes, we also need bota3, right? Because we need to access S3. Then we also want to save the results to S3 eventually. So we need to have bota3. Yeah, and then if you want to make this one nicer, you need arcparse, which is a built-in library, or click, which is not a built-in library, which has a bit nicer interface, I guess. But yeah, that's it. And then, for example, after that, you can package this in a Docker container and schedule your Docker container, run this Docker container with something like AWS Batch, for example, or ECS, or as a Kubernetes job. There are many options. What we will do next, however, is we will take the script that we wrote here and we will turn this into a prefect flow. So that's the plan for the next video, and see you soon.